Hello everyone, welcome to this new video. So in this video, there is a subject of digital communication lab, right? And for one more batch, the lab exam is pending, and we have decided to provide you this manual of this digital communication of some of the list of laboratory experiments and what and all is the procedure in the write-up part, how to write and how to execute the program, along with the procedure, theory, explanation, and circuit diagrams if necessary for all the seven hardware and software experiments mentioned in this. Okay, so we are planning to provide these things. Okay, this is our channel name VTU Academy for fifth sem branch ECE. We are providing it digital communication lab man. Okay, so these are some of the list of laboratory experiments. As you can see, hardware experiments are generation and demodulation of amplitude shift keying signal ASK signal, generation and demodulation of phase shift keying signal, generation and demodulation of frequency shift keying signal, generation of DPSK signal and detection of data using DPSK transmitter and receiver. Okay, these are some of the simulation experiments, that is coding experiments. One is QPSK modulation and demodulation part, and should be displaying the signal and constellation diagram. Encoding and decoding of Huffman codes, study and implementation of CRC, that is cyclic redundancy check, then generation of 16 QAM modulation and obtaining the QAM constellation. Okay, so these are some of the list of these experiments. So let's get to the first experiment, that is generation and demodulation of the amplitude shift keying signal. First thing is title, then you should be writing the aim. Okay, our aim is to construct the ASK generation circuit and observe the output waveform, which is observed in the CRO, that is cathode ray oscilloscope. Hope you might be knowing that is done after you rig up the circuit. Okay, also construct the ASK demodulation circuit and observe the waveform. Okay, this is the basic aim of this project or this experiment. Components and equipments required. So in order to build an ASK circuit, what and all are the components required? So one is transistor BC107, or we can use a transistor SL100. Okay, it's one and the same if you use any one of them. The resistors are 4.7K, 10K, 2.2K, 1K resistors along with one 10K potentiometer that is required for demodulator. Okay. Next is capacitor, a diode. Okay, a Zener diode, this is optional. IC741 signal generator, DSO is not required. Breadboard, power supply, wires and probes. Okay, these are some of the essential components required. So this is the theory part of ASK signal. So ASK is basically, right? In ASK is it consists of a digital message signal of zeros and ones. Okay, whenever the logic is one, that is plus 5 volt, as it is mentioned here. The transistor would be acting as a switch, and it on it. That is the 5 volt logic one would be activated, and you would be getting one sinusoidal carrier signal. Okay, but whenever the transistor switch is turned off, that is, it turns to -5 logic 0, then the output of the carrier wave which generated is 0 wave. Okay, or the amplitude would be shrink. Okay, so that's basically the amplitude shift keying signal that we'll see in the waveform. So this is the basic procedure for all the experiments which you need to be following. The first is follow precautions for personal and equipment safety. Okay, you should be staying very safe. First is that check all the components. Checking the components, probes, wires, everything is very important in order to start your experiment. Okay, because without doing that, if you directly go and rig up your circuit, then at the end, if you don't get the output, then you will be blaming others. Okay, first thing, checking all the components. Set up the modulator circuit as per the circuit diagram, that is, rig up the circuit, do the connections, switch on the other power supplies. Okay, then set this in the function generator. Okay, for all the message and carrier signals as required. Then observe the output waveforms, both message and carrier, and also ASK output simultaneously. Okay, so this is the basic circuit diagram of ASK modulator. Okay, this is the transistor BC107 or SL100, one and the same. Okay, in the collector side we have the carrier, and in the base side we have connected the message, which is a digital input, and here we have the analog input. So this is the carrier signal. As I've told you, when the logic is 1, the carrier would be passed in the modulated form, and whenever the logic is 0, there would be no carrier flow and there would be a 0. And here, whenever it is 1, again it is passed. When it is 0, it is not passed. So this is the basic ASK signal. So this is the demodulator part. okay, where the ASK output is given to this circuit, and the demodulated output you can see it here. Okay, this is the same as the message. Okay, so this is the result. Okay, whatever results till now we have obtained from whatever the waveforms we have observed, and in the CRO what waveforms you have observed, and also the changes in the waveforms. All the things you should be mentioning in the result part. Okay, yeah. Next, the second experiment, same as that of first experiment. What are all the steps required that you should be doing again. This is the phase shift keying signal. Okay, AM components required. All of them you should be writing. Theory part, phase shift keying, modulator side, demodulator side. Okay, you should be writing all of them. Procedure, I have told you it remains the same for all of them. Then circuit diagram. In this PSK, in this circuit diagram, we have a single carrier. Okay, and these two, we are using two switches here simultaneously. One transistor is SL100 and one transistor is SK100. Okay, yeah. Here, when we use SL100, we would be getting one carrier wave. Okay, in the carrier side, simple sinusoidal wave. Okay, with a constant frequency of provided here 2 volt peak to peak and 1 kilohertz frequency. And if we want to press this switch, our the phase would be changed. Okay, phase reversal takes place. Okay, so we are having one single carrier, one single message which is shorted between the base. Okay, and the outputs of these two transistors from the collector end, it is given to the op-amp IC741, one to the inverting side and one to the non-inverting side, and the BPSK output is generated here at the output of this op-amp. Okay, so this is the circuit, this is the demodulator part. So this is the waveform obtained. Okay, you can see here this is the carrier wave, and when it is 1, the phase would be getting changed when it turns to 0. Again, the phase would be changed when it turns to 1. Okay, the phase reversal takes place when the bit reversal takes place. Okay, yeah. Again, the output you should be mentioning. Next is FSK, AM components required, all of them. Theory, procedure. So in this circuit diagram, you can observe we are having two carriers. Okay, one is high frequency carrier, one is low frequency carrier. Again, the two bases are shorted, and here is the digital message input is given through a 10 kilo ohm resistor. Okay, why we are using two carriers? Because again, two transistors. When this transistor is activated, we would be getting one. What is frequency shift? Frequency shift means change in frequency, right? So first one high frequency carrier. Okay, when we on this transistor, but when this is off and this is on, we would be getting low frequency carrier. Okay, like that we should be having two carriers, and these two outputs are shorted and given to the non-inverting terminal, and inverting terminal is grounded in this case, and these are the changes, and the FSK output is provided here. Okay, so you can see this is the demodulation part, and here are the waveforms. As I've told you, this is the binary message. This is the high frequency carrier, low frequency carrier. So when the first transistor is activated, high frequency carrier is passed, and when it is 0, that is the second transistor is activated, low frequency is passed. Okay, like this the frequency shifting takes place. Next is a DPSK, aim apparatus theory, all of them. So this is basically the kit, DPSK transmitter kit. Okay, where we should be setting the values of the binary values here. Okay, 1 0, these are the switches here, where you should be setting the values of whatever the question is given. For that, you should be setting the values and checking for the waveforms. Okay, next is perform the QPSK modulation and demodulation and display the signal and its constellation. Okay, this is the coding part. Okay, should be writing the aim, procedure, and the program. Okay, here the program is mentioned here, you can see it with the comments, it's mentioned here. Also, you might be knowing is type this code, and whenever you have any error in the code, right? Okay, check for the minor errors, start from the minor errors, that is uh, the commands, right, should be always be in small letters. At the end you should be having the semicolon, all of them you should be checking. Okay, whenever you have any mistakes. So this is the waveform generated. Okay, similarly for Huffman coding also, you should be writing the code, it is mentioned here. So go through this code, go and check for output. This is the output, they have displayed, given the output here. So last experiment is study and implementation of CRC. Okay, aim, program, all of them is there, you can go through it. Okay, so yeah, that's all guys. I've tried to discuss as much as possible. So go through it, and all the best for the lab exam those who are having. So like, share, subscribe to our channel. Do support us and share this video to a huge number. Okay. Thank you.